In this example, a specialized tool is designed that only has one purpose, and so it isn't a tool that you would go down to Lowe's or Home Depot to purchase. A company might design a tool for in-house use for assembly purposes that just does one job. And so that's the idea behind this, is that it's to crimp a electrical connector onto a wire, stranded wire, and so with a certain amount of input force, either here or here or here, what is the output force generated between here and here? And then we need to define a particular location at that. But and then there's some safeties built into this, in that this can only rotate a certain number of degrees, and then it will contact the end of the slot. So that prevents somebody from over crimping the wire. And there's some other considerations in there as well. But let's take a look at this then. So I'm going to turn off the visibility of the wire connector itself, and so I'm going to say the ideal location for that is between this point and this point, and we may put some kind of geometry into the tool itself so that the operator can only put that wire into the ideal location. But that's where we're going to take our measurements from here to here, and then we're going to have an input either here or here or here to show how changing the location of our hand affects the output force that we get here. So I'm going to go ahead and go into Inventor's dynamic simulation environment, and so I put a input force at this location. Also I put one here, I could put one here. Now this one is disabled. Right now I have the force out here, and then I want to see what the force generated over here is. So in Inventor, I go to unknown force. I tell it I want the force between relative this point and this point, and this piece is the grounded piece, so I could have different components that I'm checking. But my initial position then is this is open by 15 degrees, and then I want to go to a final position of 0 degrees. That's when it's closed, and I'm going to do 1,000 steps or calculations, 1,000 calculations, or think of that as frames, 1,000 frames or 1,000 calculations of that force as the position changes. And so I'm going to go ahead and run this unknown force. And so the blue line is just the number of degrees of rotation, so that's not really important to us. But the red line is the unknown force that we're getting from our input force. Now I'm get a result here where all of a sudden the force dramatically rises, which I don't think is valid, but I'm not sure. And part of this is our mechanism is perfect, where in the real world we can't make perfect components. So this the hole between this plate and this pin is going to change position some, so we're not going to have that perfect straight line going across here. I think that could be part of the issue, is that we have a perfect model in CAD but couldn't exist in the real world. But the other consideration I have is that right now I'm showing on the x-axis the step number or the calculation number. I might prefer to have that on the x-axis the distance that this has closed between here and here. And so to do that, I create a trace, and so I'm going to say add a trace, and I want the actually I have to do 2 traces, so I'll do this position as 1 trace, and I could just visually display that trace, but I also want to calculate that trace. And this one isn't going to move, but we need that. We'll see why here in a minute. So I'll apply that, and then I also want to get the trace here, and I will record that trajectory, not just show it visually, and I'll say OK. Now I need to run it one time, so I'll rewind this. I will go to the unknown force again, and again it's calculating my output force. My input force is about 25 pounds, so I have 500 and some or 610, I guess, output force at the beginning, and then it increases, and then all of a sudden it dramatically increases. All right, so the question is that valid, and where is it valid at? I suspect it isn't valid along the whole curve. All right, now I want this rather than the calculation number or step number, I want this to be relative to how far that has closed, and so I'm going to create a new curve, and I'm going to call this crimp distance. And then I need to put an equation in here to keep track of the distance between here and here. Now this one is only moving in the XY plane, but it could also be moving in the Z plane in some instances. So in order to do that, I need to put in the formula, and it'll be easier for me to just copy this from a notepad. So I need Pythagorean's theorem to get the distance between 2 points. I'll copy that, and I will go back here and put that in for the equation. Now if the equation isn't valid, it would be red, but it's black, and so it tells us, then that it's valid. We may need to make some changes if we had to make it valid. In this case, that's okay. And then I'm going to come down here. I have a user variable folder now with that crimp distance as a user variable that is calculated. So I'm going to come back up here for the revolution, the number of degrees. That's what it's showing right now. I don't care about the revolution, so the degrees of revolution. So I'm going to uncheck that, and then I'm going to come down here to crimp distance, and actually I can uncheck that. But I'm going to right click, and I'm going to set that as my reference, or set it as my x-axis. So I'll set that as reference, and so now I have the force versus the crimping distance, which is actually we'll go ahead and play this again, and we'll see how that comes out. So the crimping distance increases as I'm coming out here. It's the crimping distance is its maximum when this is open, and so the graph is reversed. So let's just go ahead and do the unknown force again. So I'll select unknown force. I'll say OK, and this time it is calculating that force versus the position of our tool. Now it's only moving a slight little amount. That trace, the black line or black curve, is the trace. Once it completes, it will redraw the entire graph to scale it out. At least I thought it would. Now there we go. All right, so if I zoom in here, this is the same curve we had before, but now it's relative to the crimp distance rather than relative to the angle. That's what I would like to do in SolidWorks.